In this video, I'm going to talk about double replacement reactions, and when you see one, how do you know whether you actually have a reaction or whether we would say no reaction because nothing new is made. So I'm going to go through some examples here. This first one we have silver nitrate and potassium chloride potentially could make potassium nitrate and silver chloride. So does that actually happen or not? So in order for a double replacement reaction to happen, something other than an aqueous solution has to be made on the product side. It could be a gas, it could be a liquid, or it could be a solid, one of those things, but they can't both be aqueous. Most of the time we're looking for a solid to form, that would be a precipitate, or a liquid would form like water in an acid-base reaction. So if we look at this right here, then how do we know? How do we know if either one of these is going to make a solid precipitate? Well, we're going to use our solubility rules. The first one was potassium nitrate. Notice that all potassium-containing ionic compounds are always soluble, and so are all nitrates. So potassium nitrate is definitely going to be aqueous. Okay, what about silver chloride? Well, we go here and we see chloride. Most of these are aqueous, but you have to go over here and look at the exceptions. And sure enough, there's silver right there. So this means that silver chloride is going to form a precipitate. So we're going to mark this as solid. And then yes, this does actually happen because we made something other than an aqueous solution. All right, in this example here, we're going to make barium carbonate and potassium chloride. Well, we've already seen, like this one up here, that anytime we have potassium or any alkali metal, no matter what the anion is, it's always going to be aqueous. All right, but what about barium carbonate? So we're going to find the carbonates. The carbonates are down here, right here, underneath the insoluble ones. So these things here are going to be insoluble. They're going to form precipitates. Now there are a few exceptions over here of ones that would actually be soluble. So we were looking at barium carbonate. Carbonates are going to form a precipitate. Barium is not over here for an exception. So sure enough, it's going to make a precipitate. So we're going to mark this as a solid. And then therefore, yes, that reaction does actually happen. In this reaction here, our products are sodium chloride and water. Well, sodium has an alkali metal. So anytime we have sodium, it's always going to be soluble. So we're going to mark this as aqueous. And then water cannot be aqueous. Water doesn't dissolve in water. It's not how we say it. So it's a liquid. So water is going to be a liquid. So we did make something other than two aqueous solutions. So yes, this is a reaction. We got two more to look at. So let's look at this one. We're going to make sodium iodide and calcium nitrate. So sodium's an alkali metal. So all alkali metals are going to be soluble. Okay, we saw that up here. Sodium, so it's going to be aqueous. And then calcium nitrate. Well, nitrates are always aqueous, and there aren't any exceptions. So this is also going to be aqueous. Well, since we had two aqueous solutions that get made, then this actually does not happen, and this would be deemed no reaction. And the last one here, we make lead sulfate and potassium nitrate. Again, all potassiums, all nitrates are soluble. This is from our solubility table. Potassium are aqueous, nitrates are aqueous, no exceptions. What about lead to sulfate? So we go find our sulfates. Well, it looks like it's going to be soluble because it says sulfates are soluble, but we have to check out our exceptions. And there's lead 2. So lead 2 is going to form a precipitate, and so this is a solid. So yes, this reaction does happen. So anytime you make something other than an aqueous solution on the product side in double replacement reaction, then the reaction does take place.